Assalamu alaikum, dear students. So today in this live session we are going to discuss the chapter integrals. So we have studied about differentiation in your previous classes. So the chapter which we are going to see now is integrals. Integration is nothing but the opposite process of differentiation. We can also call integral. That's why we can call integration as anti-differentiation also. We can call it as anti-differentiation, or we can call the integral. The process is integration, so the other name for that is anti-differentiation. Okay, or the answer for any particular function, we call it like we know if f of x is there. If I differentiate what we call f dash of x, we call it as the derivative of f, right? Same way for any function, if I find the anti-differentiation, that is we call it as anti-derivative or integral. Anti-derivative or integral. Anti-derivative, we can call it as anti-derivative or integral. So it is, as I told you, it is nothing but the opposite process of differentiation. So to understand it more clearly, you all know differentiation very well, right? So for example, what is the derivative of x square? What is the derivative of x square? We know the derivative of x square according to the formula x power n into x power n. What is the formula for n? X power n. Derivative formula is n into x power n minus 1, right? So if I differentiate this, what I'll get? I'll get 2x, right? So if I integrate this, what I'll get? For integral, for differentiation, we'll use the symbol d dx. For integral, we will use this symbol, integral. This is the symbol we'll use it for integration dx. And whatever has to be integrated, that must be, this is the symbol. The sign, and this dx is the symbol for integration, like how we have symbol for differentiation dy dx. Same way for integration, this is the symbol. Whatever that has to be integrated, we must put it inside. Right. Now, if I differentiate 2x, what is the integral of 2x? How will you get the answer? What if I differentiate? As I told you, since it's the opposite process, what if I differentiate? I'll get 2x. If I differentiate x square only, I'll get 2x. So what is the integration of 2x? Integration of 2x is nothing but x square. Right? Is it clear? Now, differentiation of x square is also 2x. What about differentiation of x square plus 1? The derivative is, what is the differentiation? The derivative is nothing but 2x, right? So if I differentiate x square also, I'm getting 2x. So if I differentiate x square plus 1 also, I'm getting 2x. What about if I differentiate x square plus 3? Derivative of x square plus 3, that is also what? 2x. X square plus 4, 2x. Derivative of x square plus 5, 2x. So x square plus any constant, I'll get 2x. So what I can write? Integral of 2x. The integral of 2x is what? Not simply x square. We will write it as x square plus any constant. But I don't know what constant is it. It can be 1 or 2 or 3. Whatever it is, whatever constant, the derivative is 2x. So I'll write the answer to be x square plus c. That's why in integration, when we have two types of integral that we will discuss later. We have indefinite integrals and definite integral. Right? For definite integral, we will not put that plus c over here for the answer. Why we will not put that plus c? That we will discuss later. For this type of integral, when there is no limit, if you have the limit, that only if I have a limit, lower limit and upper limit, we call it as definite integral. If the limit is not there, we call it as indefinite integral. For indefinite integral alone, we will be, whenever we integrate it, we should put this plus c. For example, integration of cos x. What if I differentiate? I'll get cos x. Derivative of what is cos x? Yes. What is the derivative of cos x? What if I differentiate? I'll get cos x. What if I differentiate? I'll get cos x. Derivative of sin x is nothing but cos x. So if I differentiate sin x, I'm getting cos x. So if I integrate this, what I'll be getting? I'll be getting sin x. So integral of cos x is what? Sin x. As I told you, not only integral of sin x is cos x. Sin x plus 1, what is the integral of sin x plus 1? Cos x plus 0, cos x. Sin x plus 2, sin x plus 3. So that's why we'll put a plus c over here. Right? Like this. But in all the cases, we cannot use this concept of antiderivative. That is, Here I am just observing that what if I differentiate and I'll get this. I can easily identify if I differentiate sin x, I'll get cos x. So I can do it, right? So first exercise 7.1. Okay, before getting into 7.1, why they are using this symbol for integration? The reason is integration is nothing but infinite summation. Infinite summation only we call it as integration. That is, for example, if I have a any figure, okay, whether it is a circle or square, whatever it is. If I split into 4 equal parts, and if I give you the square area of this particular part, but I'm not giving you the actual side of the square, but I'm splitting into 4 equal parts, and I'm giving you the area of this particular part. Can you find the area of the total square? Area of the square? You can find it. Why? Because it is split into 4 equal parts. I know the area of 1 equal part. So what you will do? For example, the area of this is 3 centimeters square. What you will do? 3 plus 3 plus 3 plus 3, or 3 into 4. Right? 3 plus 3 plus 3 plus 3, you will get 12. So area of the entire square is what? 12 centimeters square, right? So, or you can either add. Multiplication is nothing but rapid addition only. We call it as what? If I want to add, I have 21 rupee coin. I have 21 rupee coin. Instead of adding it as 1, 2, 3, 4, what we can do? 21 rupee coin. So 20 into 1, 20. So multiplication is nothing but rapid summation. Rapid addition. Okay. Right? Rapid addition. Now, rapid addition only we call it as multiplication. Infinite addition or infinite summation only we call it as integration. Let me explain you what is this infinite summation. Here I am splitting into 4 equal parts, not an issue. If I am splitting into infinite equal parts, okay, I am splitting any particular, either a square or a circle. If I split into infinite equal parts, each part will be a regular curve. If I know the area of that, how can I find? Can I put infinity into, for example, I am splitting into infinite equal part. Okay. From that, I am taking from the infinite part, I am taking one part, and I am telling that area of that particular part is 0.01 centimeter square. Here I have split it into 4 equal parts. Area of one part is 3, so 3 into 4, 12. Can I use the same logic here? When I split into infinite parts, can I do the same logic? For example, area of one part is 0.101 centimeter square. Can I write 0.01 into infinity? And can I tell the area to be infinity? No, it is not possible, right? So certain concepts will fail under in some situation. So that is a key point. That is a turning point where we'll find out some new concept in which that situation has an answer, right? So here for this particular situation, that is if I split into infinite equal parts, yes, what will happen? I cannot use the concept of multiplication or addition over here. So in this case only we will use the concept of integration. So that's why integration is called as infinite summation. How many equal parts? Infinite equal parts, right? So this concept only we call it as infinite summation, which is nothing but integration, right? So in summation, what is the first letter? Yes, right? Sorry, the first letter is yes. Just pull this yes. Imagine that it is with the help of a thread. I have written this yes. You can pull it, right? So pull this upward and this downward. What will happen? This will become like this, and this will become like this. Finally, what will happen? It will become like this, right? So that is the symbol we use for integration. So from the summation, yes, the first letter, you're just pulling it upward and downward. So what will happen? It is becoming like if I stretch it, what will happen? I'll get to this symbol, which is the symbol for integration, right? Like now we'll get into 7.1. Before that, one small note, that is like differentiation. We had derivative formula, right? We had a proof in 11th standard, 13th chapter in CBSE textbook. We have seen the introduction for derivatives. We have y derivative of sin x is cos x. We had a proof in 11th standard, right? Same way for integral also we have a proof. Yes, even we will discuss that in 7.7 or 7.8. We will discuss why the integral, how we are getting the integral formula. 1 or 2 formulas we will discuss, right? But for the remaining exercise, there are around 12 exercises are there in 7th chapter. In that except one exercise, the remaining exercise, we will memorize how we have memorized the derivative formula. Same way we will memorize the integral formula, right? Let me write one or two formulas for you. For example, integral of x power n, the formula is x power n plus 1 by n plus 1, n plus 1 by n plus 1 plus c. Integral of sin x, integral of sin x, you should not tell it as integral of x power n dx. Integral means this along with this only, we call it as integral. Integral of x power n is x power n plus 1 by n plus 1. Integral of sin x is what? Integral of sin x is minus cos x plus c. Differentiation of sin x is cos x. Integral of sin x is minus cos x. Integral of cos x is sin x. Like that, we have many formulas. You can check your textbook for the formulas, for integrals. Please memorize that formula, then only we can able to do all the exercise in this particular chapter. Now, before getting into the actual integral, first we will do exercise 7.1, the first 5 sums. What they have given us, they will make you to understand the concept of integration. That is, integration nothing but the opposite process of differentiation, right? So antiderivative. So with the help of that antiderivative concept, we will find the integral. Not with the integral, without using the integral formula. With the derivative formula, what we will do? We will find the integral. That is, we will find the antiderivative without using the integral formula for the first 5 sums alone, in order to understand that integration is nothing but the opposite process of differentiation, right? Now, exercise 7.1. For example, let me take the second sum, cos 3x. Exercise 7.1. Exercise 7.1. Third sum. What they have given? For cos 3x, they are asking you the antiderivative or integral, but you should not use the concept of integral. You should not use the integral formula here. Okay, with the help of the derivative formula, you should find the integral. That is, you should find the antiderivative. And please don't get confused when I tell antiderivative. Antiderivative is nothing but integral. Antiderivative is nothing but integral. For these 5 sums alone, I will use the word antiderivative. From the 6th sum onwards, throughout this chapter, I'll use the word integral. For the first 5 sums alone, I'll use the word antiderivative. Right? Now, what if I differentiate? I'll get, don't find directly. We cannot directly find cos 3x. Now tell me, what if I differentiate? I'll get cos x. Derivative of what is cos x? Derivative of sin x is what? Derivative of sin x is cos x, right? Derivative of sin y, cos y. Derivative of sin theta, cos theta. I want cos 3x. So derivative, we know that this is the rough step, this is the main step. Okay. We know that derivative of sin x means I want cos 3x on the right hand side. No, so put 3x on the left hand side as well. Now derivative of sin 3x is what? Cos 3x. But then we have to differentiate the 3x, right? What is the derivative of 3x? Into 3, right? But I want the antiderivative for what? This alone. I don't have 3 in my question, right? So bring this 3 down. What will get? So d dx of what I'll be having? Sin 3x by 3 equal to cos of 3x, right? Now, so if I differentiate this, derivative of d dx means what? Derivative of this is this. So what can I conclude with the help of the concept of antiderivative? If I differentiate, I'm getting this. Means if I integrate this, I'll get this. Or the antiderivative of this is what? This part. So antiderivative of cos 3x is what? Sin 3x by 3. Sin 3x by 3. Got it? Right? The next sum is, let me do the exercise 7.1. Let me do the third sum, e power 2x. Third sum, e power 2x. Now, what if I differentiate? I'll get e power x. You all know. Let me write d dx of e power x is e power x, right? Yes? But I want e power 2x. So we know that according to this, derivative of, what is the derivative of e power 2x? e power x is e power x, e power y is e power y, e power 2x is e power 2x. Then I will differentiate this 2x, I must put this 2. But I need one, I have only e power 2. I want the antiderivative of e power 2x. So this 2 is not there. So bring this down. So d dx of e power 2x by 2 equal to e power 2x. So if I differentiate this, I'm getting this. So antiderivative of this is what? This part. So antiderivative of e power 2x, antiderivative of e power 2x is what? E power 2x by 2 by 2. Now you can just observe one point here, because when we get into integrals, I'll tell this thing, this topic, this part alone again. Listen, there, what is the antiderivative of cos 3x? Sin 3x by 3, right? And what is the antiderivative of e power 2x? E power 2x by 2, right? In differentiation, what we will do if we have powers like this, sin 2x, cos 2x, tan 2x, we'll differentiate with the help of that formula. Sin 2x derivative is cos 2x. Then we will differentiate the 2x and we will put into 2, right? In integration, we have to put by 2. E power 2x derivative is what? E power 2x into 2. In the integration of e power 2x, e power 2x by 2. Same way, derivative of cos 3x, derivative of cos 3x is different. Minus sin 3x into 3. Minus sin 3x into 3. Integration of cos 3x. Integration of cos 3x what? Sin 3x by 3. Okay, sin 3x by 3. If it is confusing, this point what I told now, if it's confusing, leave it. We will, after completing, when I get into that part, because we didn't go through the integral formulas yet, right? I told you to go through today. After completing the sums, you can when I get into the normal integral sums, that is with the help of integral formula we will do now. At that time, I'll tell you this concept again. So that's it. Third. Sorry, this is second sum, and this is the third sum. Right. Next sum. Let me do the fourth sum. Ax plus b the whole square. Ax plus b the whole square. If I'm going too fast, please, should we write plus c in the end of these sums? Yeah, it is better if you write a plus c over there, because antiderivative, but they're asking you the antiderivative, whether you write plus c, it will be better, but they're asking antiderivative. Okay, fine, you can put plus c. Fine. Who's that? Adnan Wasi. Since it is an antiderivative, antiderivative is nothing but integral, right? Because, but then you should have written it here and here. But don't confuse that plus c here. But plus c is, you have to write that plus c, but don't get confused with that now, because we didn't start using the integral formulas, right? So once we get into that, I'll be using that plus c. Now we are just understanding the concept of antiderivative. The rest, integration is nothing but, we are understanding this only now. Integration is nothing but the integration is nothing but antiderivative, right? Anti-differentiation. So to understand that, we are doing some sums now. So in this, don't confuse that c now. Okay, when it comes to the normal integral sums, we'll obviously, if it is an indefinite, when there is no limit, we'll be definitely using plus c over there, right? Fine. Right. So fourth sum, ax plus b the whole square. Ax plus b the whole square. What is the, we have to find what is the antiderivative of a plus ax plus b the whole square. Now, what I differentiate, I'll get square in the power. If I differentiate x cube only, what I'll be getting? Derivative of x cube is what? 3x square. Derivative of x cube is what? 3x square, right? So I have what? Ax plus b the whole square, right? So you can write it as, we know that. Why I have taken this? Why I didn't take x power 4, x power 5? Because I have square over here. So what if I differentiate? I'll get square in the power. If I differentiate x cube only, I'll get 3x power 2. So we know that dx of, I don't have x here. In the place of x, what do I have here? Ax plus b. So derivative of ax plus b the whole cube is what? According to this, x cube means 3x square. Y cube means 3y square. right? So ax plus b the whole cube is 3 into ax plus b the whole square. Then I have to differentiate this ax plus b. What I'll get? A into 1 plus 0. That is nothing but a, right? I hope you all know this derivative of ax plus b is what? A is constant, but it is a product with a variable x. So a will write as it is. Derivative of x is 1. So a into 1 plus 0. So which is nothing but a. So, but I don't have this 3 and this a over here, right? I don't have 3. I don't have this a. So bring those terms down. I have only ax plus b the whole square. So derivative of ax plus b the derivative of ax plus b the whole cube divided by 3 and a, bring this down. 3a will be what? Will be ax plus b the whole square, right? If you put plus c, it is not an issue, but as I told you, don't confuse that now. They're just trying to understand that integration is nothing but antiderivative. So ax plus b the whole square, ax plus b the whole square. Got it? Is it clear? So if I differentiate this, I'll be getting what? This. So if I integrate this, or the antiderivative of this is what? This. So antiderivative of ax plus b the whole square, ax plus b the whole square is what? Is nothing but ax plus b the whole cube divided by 3a, right? So hope you have understood this concept. And now we have one more sum, sine 2x minus 4 e power 2x. Only one more sum to understand the concept of antiderivative. Then we will get into the normal integral sums. To do the integral sums, you should memorize the integral formula. This is not so difficult. It will be similar to the differential formula only. Some small changes will be there. You can compare and you can memorize it. Okay. So fifth sum, antiderivative of sine 2x minus 4 e power 2x. So far we had a monomial, single term. Now we have a binomial, sine 2x minus 4 e power 3x. 4 e power 3x. For this I have to find the antiderivative, right? So let me find the antiderivative of this separately. I'll find the antiderivative of this separately, and in between if I put I'll just substitute here. Okay. So let me do it so that you will understand. First, let me find the antiderivative of this. What if I differentiate? I'll get sine x. Derivative of cos x is what? Minus sine x, right? So we know that I want what? I want sine 2x. So cos x means minus sine x. Cos y minus sine y. I want 2x. So derivative of cos 2x is nothing but minus sine 2x into 2. At a differentiate this 2x, I'll get into 2. Now I have only sine 2x. I don't have this minus and this 2. Bring both down. What will you be getting? Derivative of cos 2x is nothing but, derivative of cos 2x divided by minus 2. I'll be getting what? Sine 2x. Sine 2x. So antiderivative of, or let me stop here itself. Take it as equation 1. Okay. Now try to find the antiderivative. Almost I have found the antiderivative of sine 2x now. What is the antiderivative of sine 2x? This. If you want, you can write it now itself now. Antiderivative of sine 2x is what? Antiderivative of sine 2x is cos 2x, and derivative of this. If I differentiate this, I'll get this. So if I find the antiderivative of this, I'll get this. Right? Cos 2x by minus 2. So this is the antiderivative of this. Now let me get into 4 e power 3x. 4. Now don't see that 4 now. I have e power 3x, right? What is the derivative of e power x? Derivative of e power x is e power x itself. So derivative of e power 3x is what? E power 3x into 3. But I have only e power 3x there. This 3 I don't have. So let me bring it down. So d dx of e power 3x by 3 equal to e power 3x. Right. Now, right hand side I have e power 3x. But in question I don't have e power 3x. I have 4 into e power 3x. So that 4 is the problem now. Right. So simple, multiply by 4 on both sides. So if I multiply by 4 on both sides, what I'll be having? d dx of 4 e power 3x by 3 equal to 4 into e power 3x. So if I differentiate this, I will be getting this, right? So antiderivative of this is what? This. So antiderivative of 4 e power 3x is nothing but 4 e power 3x is nothing but 4 e power 3x by 3. 4 e power 3x by 3. Antiderivative of this is this. Now I know the antiderivative of this. Antiderivative of this I have found out here, right? So antiderivative of this full term, nothing. In this place, for sin 2x, you just write this. For 4 e power 3x, just write this. So antiderivative of, let me rub it. So I want the antiderivative of this, this full term, right? So antiderivative of sin 2x minus 4 e power 3x is nothing but what is the antiderivative of this, right? That in the first place, cos 2x by minus 2 minus this minus antiderivative of this is what? 4 e power 3x by 3. Yes. So antiderivative of this is what? For this, the antiderivative is nothing but this, right? So that's it. The concept of antiderivative. If you have any doubts, you can just put it there. Put your doubts there. We have still 3 more minutes to complete our live session. So let me start doing from the sixth sum. For sixth sum, to do from the sixth sum, we need the integral formula. Please today go and memorize the integral formula as well. We are memorizing differentiation formulas now by now. Please go and memorize the integral formula also. So integral is compared to differentiation. In integration, we don't have that much integration. Most of the students they may feel they will feel that integration is easy compared to differentiation. Okay, so integration is an easy topic, but the chapter is a lengthy chapter. Right, we have around 12 exercises. In each exercise, we have around 20 sums or 22 sums or 23 sums like that. But if you take any one exercise, the entire exercise will be of the same model, right? So first, let me do exercise 7.1. Let me do that. First, sixth sum, 4 e power 3x plus 1. They're asking you the integral of, since it is integral, I'll use the letter I equal to 4 e power 3x plus 1. Okay, right? Integral 4 e power 3x plus 1. So this is the notation. This and this dx is the notation. This is what we have to be. This is the term that has to be integrated. So I have to find this only. I have taken that to be my I. Okay, right? Now what I can do, I can split this. I can split it as integral 4 e power 3x dx plus integral 1 dx. Right? Now take this 4 outside. I'll be getting 4 as constant. I can take it outside of the integral e power 3x dx plus integral 1 dx. I can simply write it as integral dx. Integral dx. Now the formula that I am going to use here is integral of e power x is what? Integral of e power x is e power x itself. Okay, e power x. Then integral of that plus c. After integration, I'll finally put that plus c. Okay, right? Integral of dx. What is integral of dx? Dx is nothing but actually integral of 1 dx. Am I right? Actually, I had one only now. Right? So integral of 1 is nothing but I can write it as x power 1. Sorry, x power 0. Instead of 1, can I write x power 0? Now, if I use this formula for what is the formula for integral of x power n? Integral of x power n, what is the formula? X power n plus 1 by n plus 1, right? So this is the formula for, 1 second, I think the bottom part is not visible. Right? So integral of x power n is x power n plus 1 by n plus 1. Now if I use this formula, in the place of n I have what? 0. So x power 0 plus 1 by 0 plus 1 by 0 plus 1. So x power 1 by 1, x power 1 by 1. So x power 1 is nothing but x, no need to put. So derivative integral of dx is nothing but x. So similar pattern, In physics, you will use it of an integral of dw, work done. W is the work done. Integral of, don't forget this, integral of dw, w, integral of dz, z, integral of de, electric field, E, integral of d phi, flux, electric flux, phi, integral of d phi, phi, right? So how I am getting this, the integral of d phi phi dw with this pattern only. Thereafter I will not tell this again. So integral of dx is what? Let me write it as integral of dx is nothing but simply x. Sorry, I'll conclude with this sum today. We complete this now. Integral of dx is nothing but x, right? So if I use this formula, and as I told you in that, what is the integral of e power x? E power x. But if I have e power 3x, what I must do? 4 into integral of 3x is what? E power x is e power x, e power y, e power y, e power 3x, e power 3x. Now I have to differentiate that 3. Now I should not integrate. Don't get confused. I must differentiate. But in differentiation we will put into 3. In integration we will put by 3. Okay. E power 3x is e power 3x. Then I have to differentiate this 3x. I'll get 3. But in differentiation we'll put into 3. In integration we'll put by 3. Got it? Plus, so this part over, plus integral dx is nothing but x. Then as I told you, we'll put plus c everywhere whenever we have indefinite integral. So 4 e power 3x by 3 plus x plus c. So for this class, we'll stop with this. Inshallah, in the upcoming live sessions, we'll see exercise 7.1, the left out sums, and 7.2 and so on. Right. So thank you.